outside the device and then make the device really simple.
And an example of this that is already coming to pass is RAID. Before, in the early days, people did RAID in software because, well, nobody had done it in hardware yet. Then everyone did it in hardware and said, oh, look how much CPU we save, look how much faster it is. And now that CPUs are just so ridiculously fast, it's not even funny. It's like the CPU can do several gig a second worth of RAID parity calculation. Not many RAID cards can match that kind of throughput. And you're essentially getting it for free in these CPUs anyhow. So actually there's a couple companies, I don't know if they've actually publicly disclosed this or not, but you can read about it probably anyway, is that they're doing what's called RAID onload, which is taking the RAID functionality out of the HBA, putting it back into the CPU, and doing it there and just having a dumb, simple disk controller, in hardware again. And so, like Jeff said, back to the future. We started out in software, moved it to hardware, and now we're moving it back to software again, sort of as these cost functions change over time.
Has anyone thought about putting the T, whatever, T2, T Niagara, cheap one, right?
That's right. Yeah, well, that's not exactly a T2, but those thoughts have been there, especially if you think about it with some of the virtualization technologies. What if you were sort of to domain off a few threads worth of CPU just for this sort of thing, hidden from the operating system so people don't complain, hey, RAID calculations are taking up 4% of my CPU. It's like, no, they're not. They're on this part of the hardware you normally don't get to use anyway. So.
That's the great thing about the kernel.
That's right.
Just a question. You said in your presentation this morning how you don't have multiple mount points, or you can do multiple mount points or corrupt it, but are you, and you're going to stop multiple mount points, are you going to allow Z-pools or Z-volumes to be directly accessed by multiple servers?
Yeah.
With
caveats.
Right.
So if multiple servers are sort of doing read-only, it's relatively straightforward.
Yeah.
The multi-writer situation, we're probably not going to solve in ZFS natively. We're going to solve it sort of outside the scope of ZFS. There are two parallel file systems, or whatever you want to call them. There's Lustre and PNFS, or NFS 4.1. Both of these are what we call over-the-wire protocols. So from a client's point of view, how do I access data that's smeared across multiple machines? And then each one of those multiple servers then has to decide, for my part of the data that I'm responsible for, how do I store those bits on disk? So there are really two components. There's the on-disk component and there's the over-the-wire component. So ZFS is the on-disk component. In other words, for the portion of data that a given participant in this multi-writer scenario has to store on disk, how do I store them on disk? ZFS solves that. How do the different members of a multi-writer pool communicate with each other? That's the over-the-wire protocol. And we're developing a back-end that's going to be common between PNFS and Lustre to sort of solve that given problem. So that, and this combined with a slight change in the way that NFS mounts are handled and exported to the user means that you can have a machine, or 4 machines, that are all participating in what is logically one pool. But what's really happening under the covers is it's like a 4-way striped, object pool with PNFS sitting on top. And that server just stores a quarter of the data.
And to all that, add the ADA.
Exactly. So you ask why this takes a while? It does get kind of complicated.
How do you think that will, because at the moment we're just a standalone database, we run ZFS, we did testing internally ZFS by ourselves, and we found ZFS fast. So but if we went on a rack situation, faster, we have to do it all by ourselves because ZFS is not support.
Right.
So we have all of the speeds be comparing one to the other.
Yeah, it's really too early to tell at this point. We're not even to the point where we're happy it's working. So it's really hard to predict the performance of a bit of code that doesn't really work completely yet. So my guess is, based on the way we typically do things, is it will probably be reasonable, and you can judge for yourself what reasonable means, I guess. But It probably will not be pathological, otherwise we won't ship it.
So you'd be hoping that, if you know, in database space, you'd be hoping that that sort of the product coming in would be able to compete with, say,
We would like that to be the case. Yeah, so like I say, it's just way too early to make any real definitive statements on that.
Is it smart enough to know or swap the owner of the ZFS directly between the hosts, so one's over the wire and one's aren't directly attached to it, or?
Well, I mean, I think maybe the way to think about this is that the granularity at which we're going to do this stuff is going to be quite coarse, right? Because the one thing that we don't want to do, just to take a particular example, is have two different nodes fighting over the link count on a Z node, right? That's just completely insane, right? And people have built things like that. That's insane. We're not going to do that. So what we're going to do instead is have all the concurrency be very coarse-grained, where you basically say, I've got a certain set of servers, they're serving out certain bits of data, use things like the NFS referrals mechanism, or similar technology in Lustre. You have bits of storage pool that you carve off and hand out and say, okay, you, this node, I'm giving you 100 gig. You go chew on that for a while. When that runs out, call me back, I'll give you some more, right? Very, very coarse, so that the amount of communication between nodes that are trying to provide this service is as low as possible and sort of bulky as possible.
Right, and the way the Lustre Lustre handles this is that for a given file, the metadata for that file, like owner, modification time, whatever, is that there's a particular machine that owns that file. Today there's only one metadata server, but they're sending it so there can be multiple, but still a single inode is going to map to one of the metadata servers. Different inode may be a different metadata server. That's sort of the metadata side of things. The data side of it is they say, all right, we've got 4 machines serving data here. Well, here's essentially a mathematical function that dictates how the data for that file is smeared across these 4 machines. That way, again, once that decision has been made, at or near file creation time, each node is explicitly aware of which parts of the file it's responsible for and doesn't have to talk to its peers when it's manipulating that portion of that file.
So you won't, in case of an error, you won't lose data, a hardware error, or a user server.
In case of what?
So again, and this is where the functionality that the Lustre guys are adding in this space will sort of help us. They call it server network striping. They used to call it LAID. It's essentially RAID across several object servers. So for example, if one object server either completely vanishes off the face of the earth or decides it can't read that portion of the data, there's enough of the extra data stored on the other servers that they can reconstruct that bit that server wasn't able to give you. So there's also the sort of network RAID side of this.
2 questions, kind of one related to that. I can see a lot of work in like a compute cluster and things like that, but I have a little bit of a hard time to see how they would be able to perform in a performant sort of solution compared to running like a ZFS or something like that. When you have a like 4 or 5 database servers sharing a single data source, right? So you want to have local, you have high-speed private channels, things like that. I don't know if there might be better things if you have high-speed networking between nodes with low latency or something like that. That might be able to solve that problem. The second question is, if you wanted to do something that would bypass the POSIX layer and go directly to the DMU, what would be the best way to do that?
There's actually a guy by the name of Sam Faulkner that's working on that, and he calls it the Flatpak API, I believe. And the idea is to take the parts of the DMU that make sense for applications to use, bunch data into transactions and the transactional nature of ZFS, exposing that in a relatively stable API that has certain semantics in terms of locking and in terms of failure modes that would then go through to ZFS in the kernel that would provide that functionality through this Flatpak API. So there, some of the database guys are especially interested in that. The Lustre guys are really interested in it, and there tends to be all sorts of places where that functionality is very useful. Sort of beyond the POSIX semantics that you would typically get, and more the richer DMU type semantics. And to answer your first question, one of the things that we're also thinking about, you're asking, do we go through the front door by a fast peer-to-peer network connection there? Or do we have a pool of disks that we all cooperate with? One of the issues is it gets increasingly complicated and expensive to have a shared fabric of disks. And what becomes actually a lot simpler and cheaper is to have a very fast, wide, low latency pipe between the servers themselves that each have a more private notion of disks. You know, perhaps dual ported, you know, in the most complicated case. And then provide, essentially go through the front door through, you know, InfiniBand or some other high bandwidth, low latency network protocol, so that you don't have to pay for incredibly expensive multi-ported access to your storage devices. Does that make any sense?
Yeah, because the other basic problem is just once you start trying to extend a coherency domain across a network, it makes it virtually impossible to debug such a system and keep it actually running. Right? It's like one of the most common things that you find is people using clusters often report that, you know, what's the number one cause of downtime for a cluster? It's the cluster software, right? Where a single node would have been fine. Right? So there is a point of sort of diminishing returns because of the complexity of the thing that you're trying to pull off. And you know, a lot of the solutions, therefore, end up being along these lines of saying, in order to keep the notion that one operating system is responsible for ownership of a certain set of files at a certain point in time, if somebody wants to access those, you try to migrate the files to where the access is, or migrate the processes to where the data is that they're accessing. But or, you know, alternatively, you know, to proxy requests where you say, I want something, he's got it, you go get it, send the answer back to me. But you let the sort of lower level implementation at the level of mutexes, reference counts on data structures, you just don't want to try and share that because it's just, it becomes a nightmare. Yeah.
I remember when we did the distributed load manager for it.
Yeah.
It was fun.
Mm-hmm.
So there's a question back here first, I think.
Any plans to implement the equivalent of union effects, flag directories? Now that you could page you to hash, you just have the references in the second directory.
Yeah, for sort of like the transparent or translucent file system. It's an interesting idea. I don't know offhand if anybody's working on that right now. Do you?
Yeah, it would be something that we would do sort of not ZFS specific,
Right.
but it would be something at the Vino VFS. I know Bart was talking about this. Someone was either working on it or thinking about working on it. But it's not in danger of putting back, you know, this month or anything. So it's still very much in the early stages, part of the project. But yes, it is something that keeps coming up, which means we'll probably do it sooner rather than later.
UnionFS is not really related to ZFS. UnionFS is just, in case of FreeBSD implementation, just allows to, I don't know, stack any kind of file system.
Right, exactly.
So it's not really ZFS.
Yeah, so I was saying it'd be at the Vino VFS layer,
Exactly.
not the ZFS specific feature.
It's almost kind of like an alternative or something similar, parallel, I guess, to LOFS or,
Yep.
Although mounting particular ZFS dataset in many places in parallel would be cool.
Indeed.
It is possible, actually it's buggy, but in theory, there is one bug, particular bug, but in theory it is possible to mount the same file system read-only in many places in FreeBSD, but read-write is something else.
Yeah. It'll be on the page list.
Indeed.
Once you solve the problem with multi-write, you can actually get down to whatever you want, wherever you want.
Indeed. Yep.
I have a question for Dawidek, Mr. ZFS does a lot of things like within itself, like version compression, so How do you handle that when you port it to Jira?
Actually, it was quite, it wasn't really hard because most of the stuff I needed to port, I actually was working on FreeBSD. So once I decided to port ZFS, I had some knowledge about Geom already because I did a lot of stuff in there. I had some knowledge about file systems, also encryption. I did some work on encryption on FreeBSD, so once encryption is in ZFS, I hope to be able to port it as well. So there were some tricky bits I wasn't able to handle myself. I don't really know everything about FreeBSD. Stuff like VM is something I'm trying to avoid. But it wasn't really hard. Although it's much harder to catch up all the time because ZFS is still moving target all the time. So new stuff comes in and it creates new porting problems, of course, but
You guys migrate this to Windows?
Ask Larry.
We would have been able to give you more of an answer before, but things are kind of in flux right now.
Trying my ignorance here maybe, but when originally people needed to turn off the write flushing to avoid breaking, well, destroying the performance of their SAN connected storage, that was implemented as a single, separate system type setting. And if you had a machine which had local SAS with ZFS root, now ZFS root has come along, I haven't got a machine of access to check this. Have you broken this out as something that you can do per ZPool so that you can have ZPool on SAN, have one write caching policy, and ZPool on local disk, have another write caching policy, and have an attribute?
Well, actually, I can sort of claim responsibility for the initial bug, which is there's the synchronized cache SCSI command. In there's a spec that T10.org puts out, the SBC or SCSI block command book.
Which he reads for amusement.
Yeah, and you can't download them anymore since the beginning of the year.
Oh, really?
They don't make the drafts available anymore. You've got to pay for $30 for like X, Y, and ZW.
Save your old copies.
So the one that I had remembered reading was basically you send on this command and you're good to go. Turns out that since I had read that and the time that we went to implement synchronized cache in ZFS, actually SBC 3 I think had come out and they added fields to that command, which basically allowed you through, in one of the mode pages, there was a thing that says, do I have non-volatile cache or not? And that interacted with the new field that they added in the synchronized cache command, such that if, depending on how these two bits were set, you could send the synchronized cache that says, synchronizing into NVRAM is fine with me. Or you could say, I don't trust your stinking NVRAM. Actually send it all the way down to disk, which unfortunately, if you weren't aware whether the thing had NV cache or not, if you just had a 0 for that bit, happened to be the meaning is, I don't care if you have NVRAM, send it all the way down to disk. And so what happened was George Wilson actually fixed this not too long ago, but it was a while ago now. It was like last year. Yeah, so that now we actually do the mode sense page and set that bit appropriately in the synchronized cache command, such that we play well with the non-volatile caches. And it's just, we're sorry.
No, it turned out that there's two reasons that people want to do the synchronized cache. One is to say, I want my data to be on stable storage, and stable in the sense of, I can deal with power loss. The other is, I want to be on stable storage because, say, I want to service the battery, right? And in which case your non-volatile RAM is really going to be non-volatile as soon as you go off and do that.
So actually, you can specify in SD.conf, in the SD config list, based on matching the vendor and product string, whether or not you want synchronized cache passed to your target.
Oh.
Cool. So many ways you can skin the same cat, I guess. Do we have a question over here at one point? No? Yeah.
You're talking about bringing some of the more powerful features out of your controls back to the software. continuous replication is one of the issues we do, or asynchronous and synchronous. So what are the plans there?
Well, when you say synchronous, I guess the first question I would ask is how synchronous do you mean? As in, do you need, well, by which I mean in the sense of every single time I send a block, to local disk, do I also have to send it remotely, or can it be, maybe there's a few seconds of lag between local and remote? Because the answer ends up being very different for depending which you're looking for.
Yeah, we use true copy at the moment for our synchronous replication, where you hit one array and it won't return, it won't acknowledge until the other array is acknowledged to it.
Right.
Complete. That's very quick because it's in cache with those arrays.
Well, it's subject to whatever pipe you have between the two arrays.
That's true.
Which can be very variable, depending on your setup.
So there's also the option of asynchronous. The synchronous waits until it's acknowledged from the other.
Right, so in case where you want truly synchronous, the easiest way to do that in ZFS is just have a mirror, because that's the semantic, right? The write isn't considered complete until it's written to both sides.
The difference there is you're then reading from that remote array as well.
So you want a preferential side of the array to read from,
Exactly.
which again is something that we've discussed, but a lot of these things fall into the category of, yeah, I can do something that makes sense to me, but that having it be part of a simple, easy user experience gets to be rather tricky. It's just like we have the capability in ZFS on a per block basis to control the compression of a block. But there's no way in POSIX, for example, to say, and of course that could easily extend to per file because the file is nothing more than one or more blocks. But there's no way in POSIX to say, I want compression to be such and such on this file and something else on this other file. So while the code is perfectly capable of having a different compression function for each individual file, there's just really no easy way to go about expressing all of that. So it sort of falls into this gray area, just like the preferential side of reading from a mirror. Yeah, the code's perfectly capable of doing that with little to no modification. The expression of that gets to be tricky. And the asynchronous replication, actually our Amber Road series of products that Brendan works on, actually has that functionality. You can set up two or more. You can set a one-to-many replication or a one-to-one and then that one to another one, so a two-hop replication. But it's fundamentally asynchronous. And do you know, Brendan, sort of how fine you can control that knob of how asynchronous it actually gets?
No, that's a question I'd ask you. It's we're exporting whatever the current ZFS stuff is. So.
Okay, so it's a per transaction group
Is
thing.
that a snapshot-based replication or is that continuous?
Yeah, I believe it's snapshot based. So you can take a snapshot every transaction group and have that sent across. And
on our ZFS